Do you know why the sky gets red at sunrise or sunset? How many people know? How many people really know? This is what somebody might tell you. Sunlight encounters more air molecules when the sun is lower in the sky than when the sun is overhead. Even more blue light is scattered away, leaving mostly the reddish component of white sunlight to travel the straighter path to your eyes, so the setting looks red. Sounds good, right? Yeah. Yeah, sure. But it's not the correct answer. What I'd like to do is demonstrate. So here's a nice, beautiful sunrise, a reddish sky. Let's look at glass dispersion in colors. You've seen this image before. White light passes through a glass and it gets dispersed into the spectrum. Red is the least refracted color. Violet is the most refracted. Keep that in mind. Red is the least refracted color. Alright? Concave earth, glass sky, sunlight. Alright, let me try drawing this for you on paper. I gotta adjust my camera, but we'll see how we can do it. I gotta turn the camera upside down. 1 second here, guys. Alright. There's a camera. There we go. Alright. Sorry about the angle. That's the best I can do with this setting. Okay. Uh-oh. Get some more tape. There we go. Stay. Alright. Put the microphone over here. Okay. My trusty pencil. Now keep in mind this would be a full circle looking top down, of course. How does that work so far? Yeah, I just need a little glass sky. Alright. Okay, this is exaggerated, okay, but this would be 100 kilometers. So, move it up a little bit there, sorry about that. So, you are here. And as I told you, the sun is moving within this space. This would be considered outer space, but it's really inner space. This is the celestial sphere. This is a glass container as well. This is the glass sky at 100 kilometers that was formed after the flood. And sunlight is bending within the earth, and the sun is only a half sphere. Alright? So it's bending. If this is the east and this is the west, the sunlight is bending around like that and hitting your eye. Okay? It's bending less severe when you're closer to the sun. When it goes through this glass sky, it gets dispersed, just like going through the prism, right guys? The white light is going through here, and the red light is the amount that's least refracted, right? So you have the blue light, it's going to be, or the violet light is going to be more refracted, okay? So you're not picking up the blues, all the other colors refract too much for you to see them at that angle, at this angle of incidence. You should study Snell's law a little bit to understand how that works. So the red, because it does not refract that much, is what you pick up the most. That is the true answer. Why the sky is red. Isn't it wonderful to know the truth? Oh, let's talk about, somebody brought up a question on my YouTube about megacray meteors, and a simple fact that, excuse me, the simple fact that when we look at megacray meteors, they're opaque. What's going on there? Let's find some pictures of megacray meteors. Look at that, they're opaque. This one fell on the Mustang. Remember that one in Florida? So how can an opaque glass be covering, or I'm sorry, an opaque ice be covering up the glass sky? How does the sunlight penetrate through? It's got to be transparent, right? Yes, it does. And it is. However, it's just not transparent at ground level. Because, let's go over here. Temperature. There are two different states of ice, amorphous and crystalline. Amorphous means it's clear, transparent, like glass, and crystalline means it has structures, it has crystal structures, and it is usually opaque or very near opaque, translucent opaque. Okay? Keep that in mind. Let's go to that one reply I just made to this guy. At 100 kilometers, stop. At 100 kilometers, guys, or thereabouts, where the glass sky is and where the ice is attached to the glass sky, it is clear and it is very cold, and that's where the ice stays in the amorphous state. I just got these figures from Wiki, and I'll just read it to you. At 100 kilometers, you are just over the mesosphere, mesopause. This is where the temperature of the ice is cold enough to stay in the amorphous state. In the mesosphere, temperature decreases with increasing height. The upper boundary of the mesosphere is the mesopause, which can be the coldest naturally occurring place in Earth, with temperatures below 130 Kelvin, which is minus 226 Fahrenheit, or minus 143 Celsius. So it can be below that. It can be colder than these temperatures here. So there's a transition. Ice can go from state to state. Indiana to Illinois. No. It can go from amorphous to crystalline, okay? Based upon the temperature. In general, amorphous ice can form below minus 130 K. At this temperature, water molecules are unable to form the crystalline structure commonly found on Earth. Amorphous ice may also form in the coldest regions of the Earth's atmosphere, the summer-polar mesosphere, where noctilucent clouds exist. That's actually volcanic ash remnants, but I'm sure there's ice there too. These low temperatures are readily achieved in astrophysical environments such as molecular clouds, circumstellar disks. Okay. An additional factor in determining the structure of water ice is deposition rate. Even if it is cold enough to form amorphous ice, crystalline ice will form if the flux of water vapor onto the substrate is less than a temperature-dependent critical flux. This factor is important. Okay, blah, blah, blah. At temperatures less than 77 K, irradiation. Okay, so at that level, the temperatures are cold enough to stay clear. The ice stays clear. But once it starts getting warmer, that ice gets opaque. So that's why. Okay. Originally, I didn't know this. I mean, I was just, okay, well, maybe it's opaque up there, but once you start doing a little bit more investigation, and the questions start pouring in, but everything just falls right into place when you have that glass sky as your foundation of understanding. Isn't that great? We figured out the lunar waves, the linear polarization. We figured out where tektites come from. We figured out where megacryometeors come from. We figured out where the Libyan desert glass comes from. That's amazing. That's great. So there's my little graphic that I had made a long time ago. Okay, guys, it doesn't come from airplanes, doesn't come from windshield, doesn't come from Alaska. I sound like a broken record, I'm sorry, but just trying to help you guys understand. And, for me too, it's a process for me to comprehend what's going on too. So, it's the Lord Stephen Christ Discovery Project. Okay, that's enough for now. Bye.